and welcome to this Offshore Quick Chat. Today we'll be discussing some key engineering issues for the growing offshore wind industry. I'm Beaubouef, Managing Editor for Offshore Magazine, and today we're speaking with Yann Helle, Group Managing Director for 2H Offshore. Yann, welcome, and thanks for joining us. Can you tell us a bit about your background and the background of the company?
Yeah, thanks, Bruce. I've been, I'm the Group Managing Director of 2H, and I've been with the company now for over 21 years. And so 2H is an engineering consultancy that we've been out there for about 30 years, and we tend to specialize in the drilling analysis or the dynamic simulation associated with anything to do from cable, risers, and mooring system. And we've been now with all of the trends that we have. So we've been doing a lot of work recently also on the renewable sector.
Great. So as you mentioned, 2H has been operating in offshore oil and gas for 30 years. What trends do you see that are developing that are similar for offshore wind?
That's a good one. So it's interesting because what we're seeing right now is really, it's a bit like when we started all in the oil and gas industry. We all started in very shallow water and we're getting into the deeper and the deeper water. We are now at the phase where jackets are not enough. We are going into the floating sector. And we are seeing the same story that is being repeated again. And one of the ones that we are quite interested in is when I started in the oil and gas industry, my first boss was telling me, you'll realize one thing very quickly is that we work a lot on the umbilical and risers, which are all of the dynamic section that connect the seabed to the surface. And those represent 10% of the cost of the entire field, but they also represent 80% of all of the challenges and the issues that we're going to face in the industry. And we've been now working for the past 5-6 years into the renewable sector, and we are seeing the exact same trend. I think that most of the electrical cable that we are seeing represent 10% of the cost, but represent nearly 80% of all of the claims that are being made to insurances on quite a lot of the offshore wind farms that we're seeing.
Okay, great. So what are some of the lessons learned for the offshore wind industry on the issues of design, dynamic analysis, and life extension?
So, well, one of the things that we used to do that we're particularly bad in the oil industry at the time was gathering of data. We've been terrible to keep track of all of the information, of all of the initial design dossier, of all of what has been happening offshore. So you come towards 5-year, 10-year of production, and you realize very quickly that you are in a very bad situation when it comes to having to go into the life extension of it. There should be more emphasis that is being made upfront into gathering all of the right information. We're in the age of digitalization, that should be quite easy. And what we've been doing recently that works amazingly well, it's anything to do around predictive technology. So as long as you have the data doing some digital twin of your structures where you are inputting information about all of the wind, the structural stress that you're seeing, the type of amp voltage that you're getting, allows you very quickly to be able to come up with a solution that says, okay, we are about to encounter a problem in the next 2 years, 4 years, 5 years, and we can start to preempt some future issues. It's going to be a massive thing about the offshore wind. Is we are not speaking about just one field. We are speaking about, it's not just one turbine that we're speaking about. We're speaking about hundreds and hundreds of turbines. So the ability right now to master the data in order to help us prevent future issues is going to be prime importance when it comes to this industry.
Okay, great. So what are some of the key challenges in the early design phase of offshore wind projects?
Yeah, I'm going to say the number one issue that we are seeing right now, it's anything to do about the soil. So one of the things that's a bit different compared to the industry that we tend to work on is that the renewable sector is very focused on the levelized cost of electricity, and this is triggering lots of questions and decisions that are being made both at initial design and then during the production system. We are trying so much to reduce the cost to such a level that we're cutting corners. There's no other way to put it. If you look at the soil information that we are getting every day for fields offshore, both America or in the APAC or in Europe, you realize that there's very limited sample data because we're trying to do things on the cheap. The information that we get is for one site, but most of the wind farm are 200 kilometers square wide, and we are close to the shore. So your chances of having boulders, of having completely different type of soil varies quite tremendously. And there's an inherent residual risk when you're doing some geotechnical installation, like your foundation. Very often, we don't really master the soil. We don't really understand what's going to happen on some of those foundations. So it is a problem for the industry. I think that the soil is one, but the second one that is also quite interesting is the way we are approaching the design. I think that the oil and gas industry, usually what you do is when you do a design, you start with the idea of having something that is in place, and then you do the installation. And for the renewable industry, unfortunately, we cannot apply the same logic. You have to consider first the installation, how you're going to install it before you do the design of it in place. We are seeing an industry that is growing at a pace that I've never seen before. In 91, the turbine might produce less than half a megawatt. We are now installing some fields offshore France, and we are working on design for some turbines that are 7 megawatts. But the thing is that for 2024 onwards, all of the design going forward are 14 megawatts or 15. We are actually even doing some studies on 25 megawatt type turbine. They are bigger than the Eiffel Tower. They are absolutely gigantic. And the foundation that has been working for the past 10 years with a monopile of 8-meter diameter doesn't work anymore. So we're here, to be able to take those loads, overturning force, we need monopile that can be 12, 13, 14-meter diameter. How do you install it? How do you drill it? Do you pile it? Is there a vessel that can lift them up? Right now, there's nothing. So we are designing structures, and we don't have the means to be able to install it. So that's one of the things that we are seeing very often is we're being given parameters that actually doesn't exist right now out there.
Okay. So submarine power cables are obviously a key component of offshore wind energy. But what are the challenges with array cables on fixed wind facilities?
Yeah, so that's come back to the fact of there are loads of current issues with those. They seem to be failing quite often. And some of it is due to how they've been installed. Some of it is due to the design or others. When we have a typical umbilical electrical cable in the oil and gas, we're speaking about just one with a probability of failure of about 3%. However, when you have a big wind farm with 100 turbine out there, we are multiplying the probability by about 100. We have 100 times more termination that we have to put in place. A lot of those cables, they've been designed to be in static condition because that's pretty much what we used to do. We're going to take them, we're going to bury them under the ground. And the thing is that they're not that static, unfortunately. Because we're in shallow water, we're going to have tides, we're going to have loads of water that goes everywhere. And you have sand banks that seems to be moving slowly, very, very slowly. So you have sand dune, a bit like if you were in the Sahara, that are slowly drifting, and they can unhook a lot of those cables. So the cable burial assessment is very important. But when this happens, those cables that are supposed to be designed for static operation are going to start moving due to vortex-induced vibration or all of the good dynamic issues that we're used to see in our industry. And we are seeing that those type of solution, there are ways to prevent it. We can put some structure on top of it to make them heavier, but it costs more for the industry. So we tend potentially to try to find a way around it. And very often what's going to happen is that you're going to see that those cables have a tendency to be open to open environment, which is a bit of an issue.
Okay, so floating platforms seem to be the future of offshore wind. What are the challenges associated with dynamic cables for floating wind facilities?
So the problem that we see with floating is that right now it is being seen a bit as an extension of fixed wind. What we are doing is that we have the feeling that, yeah, we're going to take a normal fixed wind design that works in 30-meter water depth. We're going to be in 70-meter water depth. We're going to put more in line and it's going to be the same. It's absolutely not the same. There are many differences and many challenges that we have to face. So the first challenge for us, and one of the biggest one, is that floating is by no means an extension. If you look at most of the fixed wind farm, all of the cable are being connected as a daisy chain, one to each other, and then they go to a substation, and from the substation there's an export cable that goes out there. Those consideration of going with daisy chain might not be able to apply to the floating wind. We might want to consider things that are called fishbone or star type connection in order to mitigate the risk that we're going to get in case one of those cable is going to break. And those risk of cable breaking are extremely high because we try to reduce the price. So we're looking at floating system with just 3 mooring lines. But if one of those breaks, and I know we're doing the design so that it doesn't break, but if it breaks, and we know from FPSOs it happens all the time, there is no system so that the electrical cable can disconnect itself. So you're going to pull out and you're going to absolutely destroy the electrical cable that's going to be associated to a floating wind. So right now we are here, you need more mooring lines. Oh, the cost is going to be too much. Yeah, but you have to be able to control the position because if you don't have an electrical cable, you don't have electricity that comes out of it. And those type of challenges have not yet been completely fully understood. We don't have disconnectable electrical cable so that if you have a mooring line that breaks, the electrical cable has a disconnection point at one point so that you don't start dragging everything with you. So we're really speaking about components out there that are not yet designed for the floating wind. And we tend to think it's all about the mooring and it's all about the turbine and the floater. But the mooring are the first line of prevention to ensure that you still get electrical cable that are able to perform. So that's for us one of the main issues that we see out there about the floating wind is that we are yet to be able to design those cables to work, and especially to be able to work 100 times because it's not just one cable.
Okay, great. Well, thank you for those insights, Yann. And that's a wrap for today. Thanks again for joining us, Yann, and thank you, viewers, for tuning in.
Excellent. Thank you, Bruce.